Okay, this is a video for homework 8 number 3, and here we have that a manufacturer of colored candies states that 13% of the candies in the bag should be brown, 14% yellow, and so on and so forth. So a student randomly selected a bag of colored candies, and he counted the number of candies of each color. And then we have to test whether the bag of candies follows the distribution stated. So remember your null hypothesis is always the equivalency statement. So you want that, okay, that H naught is that the distribution of colors is the same as stated by the manufacturer. So is the same is your equality statement. So that's why here letter A is going to be the correct answer. So H naught is the equality, and then H sub 1 or H alternative is not the same, which is the inequality. Now next, to get these expected counts, first we have to know how many candies we're actually dealing with. So what you'll want to do is actually add up all of the frequencies here in your frequency table. So right now I'm just going to do that in my calculator. So I have 63, 66, 55, 61, 88, and 67. And when I just added those in my calculator, I got 400 candies. So what I'm going to do here, let me just open up another tab here for my calculator so you can see what I'm going to do. So for our calculator, what I want to do is I say, okay, out of the 400 candies, how many did I expect to get given that the manufacturer said that 13% should be brown? So I would say 400 times 13%. So you're going to do times 0.13, just change that into a decimal. I should have gotten 52 brown. So that's why here you'll see that it's 52. And then for the yellow, well, they got that 66 for yellow, but 14% were supposed to be yellow. So if I go back to the bag of 400 and multiply by, what was it again? 14%, so 0.14, I should have gotten 56 should be yellow. And again, they want you to round to 2 decimal places, so you do have to put the 0.00, even though I'm getting integers here. If you happen to get decimals, just round to 2 decimal places. Now, the kind of annoying part about this problem is we are going to do it in StatCrunch, but if you click to view the icon, notice I don't have anything to open this in StatCrunch, which is really annoying. And I'm also going to need my expected count. So when you open StatCrunch, we are actually going to have to go ahead and type in our data. And I actually typed this in. So just to show you how I kind of did this, because I tested it beforehand, I just went and I looked at my table here and I just copied what I had in the table. So I have 63, and then I had to keep moving this over because it won't minimize for me. So 63, then 66, then 55, and 61, 88, and 67. And then you also have to do that for your expected values, your observed values and expected values. Now we have to run what's called the chi-square test. Okay, so this is our goodness of fit test. This is what chi-square is. So we're going to go to stat, goodness of fit, and we're going to do our chi-square. And we're going to do our observed column, which is the first column I entered, and then the expected column, which is the second column I entered. And click compute. And here you can see, oops, you're going to get your chi-square value, which was 17.987 if you round to that third decimal place, and your p-value, which is 0.003. And let me just minimize this for a second, and I believe, yep, that's what they got here, 17.987 and p-value of 0.003. Now this is going to act like any other hypothesis test. If p is low, H naught must go. So if p is lower than alpha, which is 0.05, we reject the null hypothesis. But in this case, p is low, it's p003, which is less than 0.05, so we do reject H naught. So we say reject H naught, and there's 2 choices here. The reason it's letter A rather than letter C is because if you look at H naught, right, they wanted to test whether the bag of colored candies followed the distribution. So we'd say reject H naught. There is sufficient evidence that the distribution of colors is not the same as stated by the manufacturer. So that's why that is our answer, whereas letter C says there is not sufficient evidence that the distribution of colors is not the same as just stated by the manufacturers. They kind of used a double negative there. So I hope that helps. Again, that's a little annoying to have to bring your data over to StatCrunch and type it in, but it does the job pretty quickly.